Hello, Abacus users. What's up? In today's video, we are going to talk about Abacus errors and warnings. We are going to discuss the most common errors that are lurking around and annoy us the most. Now, let's see what's the difference between an error and a warning. As you see here in Abacus log, when you are faced with an error, an exclamation mark will appear next to it, suggesting that something is wrong before continuing the simulation calculation. On the other hand, a warning sign appears in a log with the exclamation mark too, but this time around, suggesting something is supposed to be corrected for more accurate results while continuing to solve the problem. Let's discuss Abacus modules. In modules of Abacus, you have certain elements to work with. First is the part. The part is where you add a 3D CAD to design or import from 3D other software that you may have. And another thing is the property. The property is information about the part that you're about to simulate. And the assembly part is where you need to have the part put in together or simply define that you are working with one part. In the next one, we have step. The definition of the simulation is in the step module. If you are to have multiple parts, you need to have interaction added. Later on, regarding the load, is forces, any moments, boundary conditions has to be added so you can understand or define your problem. The core or the backbone of FEM analysis in Abacus is mesh. The meshing the part is the most important thing. You have to have a valid mesh order in order to have a valid answer. But how you solve these errors and debugging them on Abacus? Basically, on Abacus, you're trying to simulate something. You start with an input and try to add the properties of an input. Any material needs to have a certain step to designate a solution. So we are going to add another step also regarding mesh and so on and so forth until we reach the job section. And then we are going to have the result. It is worth to note that the one thing can also hinder us our chances of achieving the good result. It is the warning. And the warning is allowing us to know that the fix is relevant and you may want to add extra information or adjustment to achieve the correct result that you're looking for scientifically. However, in continuation, we will discuss what is the error that does not allow us to achieve the result, which is the error. So, how do you know the error? The errors are shown within Abacus. It may require to change your input, change your property, change your step, or any of these sessions or the job. So, how you change or check for the property error? Let's see. The error showcases this. For example, the elements are missing from the property definition. The elements has to be identified. So what is the solution? It's just simple. Add a property of that particular thing. You go into the module menu, select and edit the material, and then you alter any information needed regarding this, which in this case, we talked about the young module. And lastly, we may have also interfere with other warnings as well within Abacus. The elements, for instance, is not properly identified for the Abacus as it warns, because Abacus is smart and telling us what we should be doing based on this. So within that hint, we are trying to set the right property. In this particular example, we select a beam that requires to be defined to be a truss beam. So within that definition, we allow Abacus to move on with its simulation. So we will go into the mesh module in Abacus and select the element type as beam truss. These step errors are basically the ones that regards to the step. So increment size, the mission of the Abacus is try to solve these one by one. It says no step definition was found. So what do? The solution is to define a step. So the step, you go into on a module menu and create a step for yourself. And on that, you can select from the general or explicit to make a dynamic or geostatic or any other simulation you have in mind. We face certain errors on the mesh. It simply says the following part instance are not meshed. So what do? So you go on the mesh part and then try as fix that as a solution. You go on the module of the mesh, select local seeds, for example, if it has to be from the seeds, you try to allocate or select the part that you want. And basically, because you can only select the part, and then you mesh the part that you want. In this case, we meshed a beam. We allow our infrastructures to face certain loads. It could be force or certain force, momentum, anything such that. And in this regard, it has to be stabilized. But then the error may face, it says the time required is less than a minimum. Usually, this is just an idea of how we should be doing that. Ideally, we should change the load, or in some cases, we change the minimum increment size in the step module from the default value to something smaller like 10 to the power minus 9, which often than not, the issue can be resolved this way. On this error particularly, it says there are too many attempts are made for this increment. So how do you do that? How do you have the solution for that? You simply adjust the load to be added, so make it to be stable. So you go on a module on the load part, load manager, and then create a new load or simply adjust the load. So based on this, you can allow the simulation to move on. There are other reasons as to why too many attempts error is happening. We will be covering this fully in another video, which you can check it out right here. So too many increments, if it needs to be needed, the error will be popping up like this. So the solution is simply, as we discussed, increase the maximum number of these increments in the step. And under the edit menu of the module, you will select the edit, and then you will select the maximum number of increments. And simply, in this case, we increase the number of 100 to something maybe 1,000. And then we move on to the density. It says no density has been specified for material 1. So how should we do it? Materials are supposed to be part of the property, right? So simply adding the density in the property menu. Go to the property module and select and edit the property. And from the general part, you'll select the density and then add the module you need. And in this case, the steel is having that amount that we just added. So the error is, for instance, saying linear cinematic hardening requires 2 yield stress values for each dependency. So we will need something to be as a solution. One part is to define 2 points. So having go to the plasticity and select plastic on the property menu. And on that, you will add a part where the plastic strain is 0 because it's not yet move on to that phase to be hardened. And then it could uses the next data to start the simulation for the hardening simulation. So I want to thank you for listening to me and also having no issue simulating to your next project using Abaqus. Have a good one. Peace.